This lesson deals with supplemental problem 4.7. You can find this problem in the ECE302 ebook in the Chapter 4 Supplemental Problems on page 13. Given these two MOSFET transistors, where here's the gate of transistor 2 and the source and the drain, and here's the gate of transistor 1, the source and the drain, where the gate to drain is shorted for transistor 2 and the drain to gate is shorted for transistor 1. Could you find the voltage V if the value of K for M1 is 8 microamps per volt squared with a threshold of 0.8, and for M2 K is 25 microamps per volt squared with the same threshold voltage? Since the drain to gate of 1 and the gate to drain of 2 is equal to 0, which are both less than the threshold voltage, and the current ID1 has to equal ID2, which is probably greater than 0 since we have a battery and some pieces of silicon, I'm going to guess that I'm in saturation. Since ID1 equals ID2, we could set their saturation equations equal to each other, where K1 is 8 microamps per volt squared and K2 is 25 microamps per volt squared. We could divide by 8 micro, take the square root of both sides of the equation, just this term and just this term. This square root of this quantity is 1.768. Multiplying that times this, then multiplying that times this, I get minus 1.414, and then the point on the other side of the equation. The gate source of transistor 1 is in terms of the gate source of transistor 2. I combine these two together and get minus 0.6142. Our circuit on top, the rise in voltage is 5, the drop is the source to gate of 1 and the gate to source of 2. I have another equation that relates the gate source voltages, and that their sum is equal to 5. I solve for the gate source of 1 by putting this on the other side of the equation, and then setting it equal to this. Now I can solve for the gate source of transistor 2. Bring this term over here as 5.6142. Bring this over here, now I get 2.768 times the gate source of 2. The gate source of 2 then is this number divided by this number, and that's 2.03. That's actually our value of V on top. Here, the gate source of transistor 2 is the same as V. I go back and solve for the gate source of 1. It's going to be 5 minus the gate source of 2. Subtracting this from 5, I get about 3, 2.97. Now since the source to gate of 1 and the gate to source of 2 is greater than threshold, which is 0.8, and the drain to gate of 1 and the gate to drain of 2 is equal to 0, which is less than threshold, then our assumption checks. This circuit is also called a voltage divider, and we'll see later in IC design courses that resistors take up a lot of space on an integrated circuit chip. We try not to use resistors. In this case, we're going to use two transistors, and by playing with their areas, in other words, their gate, width, and length, we're able to pick any voltage we want divided down from the power supply. This is a great building block in ICs. And this is supplemental problem 4.7.